Imagine a world where training the next GPT-5 or running a vast AI research lab costs pennies in electricity instead of millions, and its carbon footprint is negligible. Sounds like science fiction, right? Well, yesterday, a company few had heard of dropped a bombshell that could make that future a reality, forever altering the AI landscape. For years, we've watched the insatiable hunger of AI for computational power grow exponentially. Training models like OpenAI's GPT-3 used an estimated 1,287 megawatt hours of electricity, enough to power over 100 U.S. homes for a year, and emitted carbon equivalent to multiple round-trip flights from New York to Beijing. The NVIDIA H100, the current workhorse of AI, can pull up to 700 watts per chip, and data centers house thousands of these, requiring monumental cooling systems that guzzle water and energy. This isn't just an economic problem, adding billions to operating cost. It's a looming environmental crisis, with data centers already consuming roughly 1 to 2% of global electricity and projected to skyrocket. Everyone knew something had to give. Enter Aether Labs, a relatively quiet startup that has just unveiled what they're calling the Lumen Core architecture. This isn't just an incremental improvement. It's a paradigm shift. Instead of relying on traditional von Neumann architectures, which constantly shuttle data between the processor and memory, a process known as the memory wall that wastes enormous energy, Aether Labs has implemented a novel form of in-memory analog computing. Think of it like this. Current chips are like a chef constantly running to the pantry for every single ingredient, while Lumen Core is like having all the ingredients on the cutting board, processed directly where they are stored, using much less energy. Their proprietary photon-assisted analog compute unit, or PACU, significantly reduces the voltage swings required for calculations. While precise benchmarks are still under review, early reports suggest an astonishing 100x improvement in energy efficiency compared to the current top-tier GPUs, measuring processing in mere picojoules per operation. This means a Lumen Core AI accelerator drawing just 10 watts could potentially match the inferencing power of several H100s combined, slashing heat generation and cooling needs dramatically. The implications of this are nothing short of revolutionary. Economically, the cost of developing and deploying large-scale AI just plummeted. Smaller startups and research institutions could suddenly compete with tech giants, democratizing access to cutting-edge AI. Imagine what a small team could accomplish with a server rack consuming the power of a few light bulbs, delivering the performance of a supercomputer. Environmentally, this could halt or even reverse the projected surge in AI's carbon footprint. Less energy consumption means fewer fossil fuels burned, less water used for cooling, and smaller, less resource-intensive data centers. We might see AI agents integrated into everyday devices in ways previously deemed impractical due to power constraints. From hyper-efficient smart cities to truly autonomous edge computing. Of course, getting developers to port existing models to a new, radically different architecture will be a challenge. and scaling manufacturing will be immense. But the potential upside is too great to ignore. This isn't just about faster chatbots. It's about a sustainable future for the most transformative technology of our time. It begs the question, if the power crisis isn't entirely over, has Aether Labs at least given us the crucial first step toward taming AI's monstrous energy appetite? What kinds of applications become possible when the power bill is no longer the biggest barrier? Let me know your thoughts in the comments below. And if you want to stay updated on how AI is changing our world, hit that like button and subscribe to Scribble Stokes for more.